Here we can see that the 3D model file from our file system has been loaded and outputted to the console with the meshes that it contains. In these demos, we're only going to be using the first mesh, the number of vertices, faces, and the size of the mesh, which is especially useful for comparing this mesh to other meshes in your scene to know how big it will end up being, along with some information about what this 3D model file contains. This demo shows a 3D model that we just loaded rendered onto a 2D screen. The Z component of each position has been set to 0, which means no matter how far away it was from us, we just render it to the same place on the 2D screen. Because of this, it doesn't look very accurate, but this gives us a rough estimate of what it could look like. And we also get these artifacts where you see triangles through other triangles, which will also be resolved later on. The following file has been loaded into memory, and here is some information we can retrieve about that file. Our texture, which was loaded from the file system into random access memory, has now been moved to video memory so that it can be rendered onto the screen. Similarly to how we loaded a single texture from the file system into memory, we can load 6 sides of a cube to form a cube map. For each of these, we have which direction this faces in the cube map, its name in the file system, and the same information that we had about the other texture. Now we can see these 6 textures that we loaded from the file system rendered onto the screen. As you can see, this looks pretty morphed in the corners of each of the textures. And this is because we want to make sure that it looks like a full sphere when it's rendered as a cube. Here, in this demo, we're actually rendering the direction at each of the corners and interpolating between them to find the direction we should be sampling from in the cube map. The cube map has now been rendered into 3D simply by spinning the vectors that we are sampling from in our interpolation